In this lecture, we will discuss about the topic deep recurrent networks. This deep recurrent networks are advanced sequence processing models designed to learn patterns that evolve over time by combining memory and depth. Unlike the basic RNN that has a single recurrent, basic RNN will always have the single recurrent layers. A deep RNN stacks multiple recurrent layers on top of each other, allowing the network to learn information at different levels of abstraction. Each layer captures temporal features from the sequence, while higher layers understand more complex and long term relationships. This makes deep RNNs especially powerful for tasks involving sequential data such as speech recognition, language translation, text generation, biomedical signal analysis, and time series forecasting, where understanding both past context and hierarchical patterns are essential. We'll see one by one. First, what is a deep recurrent neural networks? A deep RNN is an extension of a basic RNN where multiple RNN layers are stacked in this case. That means a deep RNN is formed by placing one RNN layer on top of another. Instead of having one layer that processes sequences data, multiple layers are used. Each layer receives the output of the previous layer, allowing the network to learn information at different levels of complexity. The stacking makes the network deep, similar to deep feed-forward neural networks. And it is designed for sequential data, that means text, speech, signals, and time series. Deep RNNs are mainly used when data comes in order where previous values influence future ones. Examples include sentences, word sequences, speech signal, ECG, EEG, biomedical signals, stock prices, and weather data. The model understands patterns over time rather than treating each input independently. And here in this case, each layer learns temporal features. Every RNN layer learns patterns that change over time. The first layer may learn simple time-based patterns, while higher layers learn more complex relationships across long time spans. Deep layer captures higher level patterns. That means lower layers might detect basic trends or short term patterns, while deeper layers combine this information to understand more abstract or long term dependencies like sentence meaning in language tasks. Next, why recurrent? See, first we should know what do you mean by recurrent. Recurrent means replacing again and again or happening repeatedly over time. In recurrent neural networks, it means the network reuses its previous output, that means memory, and feeds it back to itself at the next step. And here, simple understanding how you are going to understand means a recurrent system remembers the past and it uses it again while processing new information. For example, when reading a sentence, you remember previous words to understand the current word. That repeating use of past information is recurrent behavior. Here, RNN have, as I've said, memory. Unlike traditional neural networks, RNN store information from previous time steps in hidden states. This memory helps the network remember past inputs. The output depends on the current input. The present data point contributes directly to the output, just like in other neural networks. Output also depends on previous hidden state. The hidden state from the past time step carries past information. So the model considers both present and past data to make decisions. And it allows understanding sequences are in the order because past information is remembered. The order of inputs matters. For example, dog bites man and man bites dog have different meaning. Next, deep. This is the architecture of the deep RNN. Here, the information flows horizontally through the time. Through time, the arrows moving across the time steps represents the memory. hidden state pass from one time step to the next, and allowing the model to remember past information. And information flows vertically, that means through layers. The stacked RNN layers past, that is a past process, a layer past processed information upward. Each layer refines the sequence representation. Here H1T and H2T represent the hidden states. These memory units, the layer 1 and layer 2 store basic sequence information, and layer 2 stores more abstract sequence features. So the mathematical equation of the deep neural network is being given by the hidden state is given by H1 of t is equal to f of Wx1. From this we are writing Wx1 into x power t, wh1 h1 of t minus 1 plus b1. And the hidden state 2, layer 2 hidden state is given by this equation. H2 of t is equal to f of, here instead of h1 it has to come x2, and h1 should come, in this value should come, and wh2 of t minus 1 plus b2. And this is the output equation. Y of t is equal to g of wt h2 of t plus by. So this equation shows that how first layer combines current input and the previous memory to produce new hidden states. And the layer 2 hidden states, in this case, the second layer uses the output of the layer 1 plus its own past memory, enabling deeper feature extraction. And the output equation is given by the final output is calculated from the top layers of the layers in the hidden state, converting learned sequence information into predictions. So here X is the input at time, H of t is the hidden state, W is the weight matrices, F it is the activation function. Here we are using tan H or ReLU functions can be used, and the output functions we are using it softmax or linear functions may be using it. And next, how deep neural networks works. Input layer, here input sequence enters into the, see here, input layer enters into the deep layer, that is RNN layer 1. The raw sequence data is first processed by the first RNN layer. The layer 1 learns the basic temporal features, and it captures short-term patterns like local signal changes. And the output layer 1 goes to the layer 2. In this figure, we can able to identify. It goes to the layer 2. The next layer refines the representation further. And the layer 2 learns the complex patterns. This layer captures the long-term dependencies and abstract relationships. Finally, the final layer produces the prediction, and the output layer converts the learned information into final results. Why deep instead of single RNN? Deep neural networks instead of single recurrent neural networks. It learns a simple here. It learns the simple pattern. Single RNN learns the simple, and here it will learn the complex patterns. Here a single RNN may miss the deep relationship, and deep RNN capture the layered patterns. And the deep RNNs from the hierarchy of features, and here the low versus higher means depth often improves performance on complex tasks. So it will be using for complex patterns, hierarchical learning, and higher accuracy, whereas it has been limited, low accuracy it produces, it learns only simple patterns. What are all the advantages of this deep RNN? It captures the long-term dependencies, and deep RNN better remember distant past information. It handles sequential data effectively, and designed specifically for time-based data, better feature representations, multiple layers extract richer features in this case. Some of the applications of RNN are, each application uses the sequence understanding. It is being used in the speech recognition in the audio sequence, and the translation in the word sequence, ECG, EEG signal analysis in the signal sequence, and it is being used in the stock market for analyzing the time sequence, and text messages for generating the text generation language sequence it is being used. So finally we can say that deep RNN is equal to memory over time plus multiple layers of sequential learning. So this is what about deep RNN, recurrent neural networks. It has got many advantages and applications like this. Hope everyone understood this topic about deep RNN. The remaining things we'll discuss in the next lecture. Thank you.